According to the National Electrical Code, lighting fixtures must be wired using a separate neutral wire for each branch circuit. The primary reason for this requirement is to prevent the possibility of accidental contact between the neutral wire and the ground wire. Such contact could create a short circuit, potentially leading to a fire hazard. In a scenario where a three-phase power source is utilized and the layout incorporates three lighting branch circuits sharing a common neutral, this configuration is not compliant with the code and necessitates correction. To rectify this situation, it is essential to run separate neutral wires for each individual branch circuit. This can be achieved through the implementation of a multi-conductor cable or by running discrete individual wires for each circuit. Upon establishing separate neutral wires for each branch circuit, these wires must be securely connected to the neutral bus bar located within the electrical panel. Let's delve into the specifics of wiring lighting fixtures correctly using a three-phase power source. Firstly, each branch circuit must have its dedicated neutral wire. Secondly, each neutral wire is independently connected to the neutral bus bar inside the electrical panel. This wiring configuration adheres to the requirement set forth by the NEC. It is crucial to understand the underlying principles that necessitate separate neutral wires for each branch circuit, especially in three-phase systems. A shared neutral in a multi-wire branch circuit, particularly with nonlinear loads such as electronic ballast common in lighting, can lead to excessive current in the neutral conductor. This excessive current is due to the additive nature of harmonic currents, specifically the third harmonic and its multiples, which are in phase on the neutral conductor and do not cancel out like the fundamental frequencies due in a balanced three-phase system. This overloading of the neutral conductor can cause overheating, insulation damage, and potentially a fire. The NEC addresses this concern in several articles, including those pertaining to multi-wire branch circuits and neutral conductor sizing. It mandates that the neutral conductor be sized appropriately to handle the anticipated maximum neutral current, especially when significant nonlinear loads are present. In many cases, this may require increasing the size of the neutral conductor compared to the phase conductors. Furthermore, the NEC requires that multi-wire branch circuits be protected by means of simultaneously disconnecting all ungrounded conductors at the overcurrent device. This is typically achieved by using a 2-pole or 3-pole circuit breaker, depending on the configuration of the circuit. This requirement ensures that if one phase of the circuit is overloaded, all phases will be disconnected simultaneously, preventing a situation where the neutral conductor could be overloaded due to current from the other phases. Grounding is another critical aspect of electrical safety in lighting fixture wiring. The grounding conductor provides a low impedance path for fault current to return to the source, tripping the overcurrent device and quickly de-energizing the circuit. This minimizes the risk of electric shock and equipment damage. All metal parts of lighting fixtures, including the enclosures and mounting hardware, must be properly grounded. The grounding conductor should be connected to a grounding electrode system that meets the requirements of the NEC, ensuring a reliable path to earth. Sizing conductors for lighting circuits is also an important consideration. The NEC specifies minimum conductor sizes based on the ampacity of the overcurrent device protecting the circuit. It is essential to select conductors that are rated for the maximum current they will be carrying, taking into account factors such as ambient temperature and the number of conductors in a raceway or cable. Undersized conductors can overheat and cause a fire hazard. When wiring lighting fixtures, it is important to use approved wiring methods and materials. The NEC specifies various wiring methods that are permitted for different applications such as conduit, cable, and flexible cords. Each wiring method has its own set of requirements for installation and support. Using the appropriate wiring method ensures that the wiring is protected from physical damage and environmental factors. Proper installation of lighting fixtures is also crucial for safety. Fixtures should be securely mounted to the building structure and supported in accordance with the manufacturer's instructions and the NEC. Connections should be made using approved connectors and terminals, and all wiring should be neatly organized and protected from damage. It is important to follow the manufacturer's instructions for installing and maintaining lighting fixtures. These instructions provide valuable information about the proper wiring, mounting, and operation of the fixtures. Ignoring the manufacturer's instructions can lead to safety hazards and premature failure of the fixtures. Regular inspection and maintenance of lighting fixtures are essential for ensuring their continued safe and reliable operation. This includes checking for loose connections, damaged wiring, and signs of overheating. Any problems should be corrected promptly by a qualified electrician. In addition to the NEC, local electrical codes and regulations may also apply to lighting fixture wiring. It is important to check with the local authorities to determine the specific requirements in your area. These requirements may be more stringent than the NEC in some cases. Working with electricity can be dangerous, and it is essential to take precautions to protect yourself from electric shock. Always de-energize the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. The NEC is updated every 3 years, and it is important to stay up to date on the latest requirements. Changes to the code can affect the way lighting fixtures are wired and installed. Subscribing to an electrical code update service or attending training courses can help you stay informed. Understanding the principles of three-phase power is essential for properly wiring lighting fixtures in commercial and industrial settings. Three-phase power provides a more efficient and reliable source of electricity than single-phase power. It is important to understand the voltage and current relationships in a three-phase system, as well as the different wiring configurations such as Y and delta. Proper grounding is particularly important in three-phase systems to ensure the safety of personnel and equipment. The NEC provides detailed requirements for grounding three-phase systems, including the size and type of grounding conductors and the location of grounding electrodes. When working with three-phase power, it is important to use caution and follow all safety precautions. High voltages can be present, and it is essential to de-energize the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with three-phase power, it is best to hire a qualified electrician to do the work. Here are some additional considerations for wiring lighting fixtures in specific applications. In hazardous locations, such as those containing flammable gases or vapors, explosion-proof lighting fixtures must be used. These fixtures are designed to contain any internal explosions and prevent them from igniting the surrounding atmosphere. The NEC specifies the requirements for explosion-proof lighting fixtures and their installation. In wet locations, such as bathrooms and outdoor areas, weatherproof lighting fixtures must be used. These fixtures are designed to protect the electrical components from moisture and prevent electric shock. The NEC specifies the requirements for weatherproof lighting fixtures and their installation. In corrosive environments, such as those containing chemicals or salt spray, corrosion-resistant lighting fixtures must be used. These fixtures are designed to withstand the corrosive effects of the environment and prevent premature failure. The NEC specifies the requirements for corrosion-resistant lighting fixtures and their installation. Emergency lighting is required in many buildings to provide illumination in the event of a power outage. Emergency lighting fixtures must be connected to a separate power source, such as a generator or battery backup system, and must be automatically activated when the normal power supply fails. The NEC specifies the requirements for emergency lighting systems. Lighting control systems can be used to improve energy efficiency and provide greater flexibility in lighting design. These systems can be used to dim or switch lights based on occupancy, daylight levels, or time of day. The NEC specifies the requirements for lighting control systems. The installation of lighting fixtures should always adhere to the guidelines outlined in the NEC and any applicable local codes. Proper planning, careful execution, and thorough inspection are crucial to ensuring a safe and reliable lighting system. The consequences of improper wiring can be severe, ranging from equipment damage to fire hazards and electric shock. Therefore, it is essential to approach lighting fixture wiring with diligence and attention to detail. In addition to safety, proper wiring also affects the performance and longevity of lighting fixtures. Incorrect wiring can lead to voltage drops, reduced light output, and premature failure of the fixtures. By following the NEC guidelines and best practices, you can ensure that your lighting system operates efficiently and reliably for many years. It is also important to consider the energy efficiency of lighting fixtures when selecting and installing them. Energy-efficient lighting fixtures can significantly reduce energy consumption and lower utility bills. There are many different types of energy-efficient lighting fixtures available, such as LED and compact fluorescent lamps. The NEC provides guidance on the selection and installation of energy-efficient lighting fixtures. Furthermore, consider the impact of lighting on the environment. Improperly disposed of lighting fixtures can release harmful pollutants into the environment. It is important to recycle used lighting fixtures whenever possible. Many municipalities have programs for recycling fluorescent lamps and other types of lighting fixtures. By recycling used lighting fixtures, you can help protect the environment and conserve natural resources. Selecting and installing lighting fixtures is a complex process that requires careful consideration of many factors. By following the NEC guidelines, best practices, and the manufacturer's instructions, you can ensure that your lighting system is safe, efficient, and reliable. Remember to always prioritize safety when working with electricity and to consult with a qualified electrician if you have any questions or concerns. By adhering to these principles, you can create a lighting system that meets your needs while also protecting the safety of yourself and others. The NEC is a comprehensive document that covers all aspects of electrical wiring and installation. It is essential to have a copy of the latest edition of the NEC and to consult it whenever you are working on electrical projects. The NEC is available for purchase from various sources such as the National Fire Protection Association and online retailers. In addition to the NEC, there are many other resources available to help you learn about electrical wiring and installation. These resources include textbooks, training courses, and online forums. Taking advantage of these resources can help you improve your knowledge and skills and ensure that you are working safely and effectively. Wiring and installing lighting fixtures is a task that should be approached with caution and respect. Electricity is a powerful force, and it can be dangerous if not handled properly. By following the NEC guidelines, best practices, and the manufacturer's instructions, you can minimize the risk of electric shock and other hazards. Always remember to de-energize the circuit before working on any electrical equipment and to use insulated tools and personal protective equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. They are trained to handle electrical projects safely and effectively. Hiring a qualified electrician can give you peace of mind knowing that your lighting system is installed correctly and that it meets all applicable codes and standards. Ultimately, the goal of proper lighting fixture wiring is to create a safe, efficient, and reliable lighting system that meets your needs. By following the principles and practices outlined in this narration, you can achieve this goal and enjoy the benefits of a well-designed and properly installed lighting system. Keep in mind the importance of regular maintenance and inspection to ensure the continued safe and reliable operation of your lighting system. Addressing any issues promptly can prevent more serious problems from developing and extend the lifespan of your lighting fixtures. Finally, remember that the NEC and other electrical codes are constantly evolving to reflect new technologies and safety concerns. Staying up to date on the latest changes is essential for ensuring that your lighting system remains compliant and safe. Engaging with industry professionals, attending training courses, and subscribing to relevant publications can help you stay informed and maintain your expertise in the field of electrical wiring and installation. Consider also the environmental impact of your lighting choices. Selecting energy-efficient fixtures and adopting responsible disposal practices can contribute to a more sustainable future. LED lighting, for instance, offers significant energy savings and has a longer lifespan compared to traditional incandescent or fluorescent lamps. When replacing old lighting fixtures, explore the available options and choose those that minimize energy consumption and environmental impact. In conclusion, proper wiring of lighting fixtures is a multifaceted process that requires a thorough understanding of the NEC, adherence to best practices, and a commitment to safety. By prioritizing these aspects, you can create a lighting system that is not only functional and aesthetically pleasing but also safe, efficient, and environmentally responsible.